Okay. Okay, please be noted, now we are in a recorded class. Okay, and now we can check the log file. Let's see what we have there. I believe we will have many. Okay, and this is, we were in save preprocessor and the first element type. Then I start to delete everything, okay, because I copy paste this thing there, if you remember. And then I add one element type number 2 with 182, and then I delete it. Okay, so this is the interpretation of the commands. And then this is for material type. I define the Young's modulus and Poisson ratio. And for this one set, start and set, I start to have these parameters there. And then later on, I have again defined this EX and the PRXY according to these values. So for instance, we can have this in the macro file before modeling. We can have one section of predefined parameters, if this is the way you prefer, okay? But again, this is not mandatory. You can use the values, real values there. But I think it has some advantage. At least it's easier to check what is the value defined. And later on, you can just change this predefined parameter part without changing anything later on. And then this one where we have this, I will copy it and paste it there, okay? So with this, we have this step number 1 and step number 2. Of course, we can copy paste everything there and go to ANSYS. I will paste this commands there, enter, yes. Okay, then if we check, just to check if everything is okay, element type, yes, it's there. For the material properties, yeah, we have to click again and they are there. So next we can do the density of the steel. So the value will be more or less like this. Of course, it differs a little bit. It differs a little bit from case to case. Okay. And then we have density there. By the way, the material properties could be temperature dependent. That's why we have this add temperature and delete temperature option. But in our case, we don't include these temperature dependent materials. So everything is based on just the default temperature. Okay, okay. Then go to log file. We have this definition of the density. So we can go to this one, paste it here. And of course, again, it could be a real value, or we can, now we can, even you don't use APDL before, but following the same type. So what you can do there, you can type set and density, but the name is your preference. I mean, you can say dense or density like this or anything like den. So we can say this is like this. And if you have a space there or many space there, it doesn't matter. If you want to make them separate, looks better, yes, it's possible. Or without this space, there's no problem with that. And then in this case, I can paste another thing to say this is dense. the small letters and the capital letters, it doesn't matter. They are the same thing, this small dance and the capital dance. Okay, this sometimes I use this exclamation mark to deactivate one sentence. This is useful also if you want to play with your APDL and try to think. Sometimes you have more than one option, so you can type them both there and deactivate one and try to activate the other one. Or alternatively, I can use the first one and deactivate the second one. This way is better if you delete this one and then you try the other one, and then the other one doesn't work well, so you have to go back to the first one that you deleted. So it's better you have many there and then just use this exclamation mark to deactivate one of them. Okay, then later on, let me check the time. Later on, probably I will go a bit faster without checking always this APDL and paste there. I will finish this modeling part, and then let's go back to APDL. So what is the next step? If you have this APDL by your side, if you have this class PDL file by your hand, next step we have to define the nonlinear material. Now it's in nonlinear elastic. I think it's in elastic, rate dependent. Okay, that is also a problem from, it's here, multilinear. Okay, then there was just one type, one group of one line there for strain stress. So I will put here, instead of the real value, for practice point of view, I will just put 1, 2, for instance, there. And we can add one more point for 3 and 4, and add some more for 5 and 6. And we can try to make a graph, okay? So this is the graph of the data that your input. So it's starting from origin and to the first point, second point, third point. Okay, edit. 3, 4, 5, 6. I didn't click here. Okay, then this will be there. Make a graph of it. Okay, and let's see what. And in this way, actually, I think it might be easier to use the APDL. If you go to the log file, you will have this MISO, M-I-S-O there. Okay, this appears also in the PDF file that I uploaded. So it could be like this, and of course these values has to be changed. The strain will be 0.000 something, and this stress could be like 400. Depends on the yield stress of the material. Normally the first value is the yield stress. So let's say 300. If we want to use 300 MPa. So in SI unit is 300 times 10 to the power of 6. Or it could be just like this. Okay, 300 E6. Or you say 3 and E8. This is the same thing. They both work. Okay, then you, of course, you will have the second value of strain and the second value of stress. Let's say a little bit more like this. Okay, and we have to pay attention here. The first stress over the first strain has to be equal to the material properties of the Young's modulus. Okay, if you know the mechanical material engineering part, in this stress strain curve, the linear part or the slope or the gradient of the first linear part has to be equal to the Young's modulus of the material. If this is not satisfactory, a warning will appear probably there during, not in the definition of the material, but later on when you start to solve your model, there will be a warning or even an error there. Okay, this is for the nonlinear property. Then probably we can start to do the model. We can create a cylinder, its volume, cylinder, hollow cylinder there. Here you can say what is the x, y. These are the center. Okay, they can be 0, 0. Or it's possible you don't put nothing there. Okay, because the default value is a 0. So you just say what is the radius number 1. This depends on the size of your pipe. Okay, I will give a random value. Let's say is with 1 meter. Okay, again, there's no unit, so I'm using SI unit. So 1 is 1 meter. So radius number 2 is 0.9. Okay, because a hollow cylinder means between this radius number 1 and number 2, this is the thickness of the pipe. So at depth, I say this is at 10. And okay, then you will have this one. This is just a 2D, and you can check with isometric view, for instance, like this. Okay. So then in this case, you will have already a pipe. Then depending on different modeling technique, you will need just to cut a small part out of there. So what I do is like this. I create another one, a new one, with let's say 1 to 0.95. Maybe 0.9 to 0.8. And with depth, this depth is actually the length of the pipe. Okay. Replot. I think I did something wrong because this length has to be 10. I had just 1 there. So now I have to delete this volume number 2. Okay. Did I make it clear? I made a mistake there. If we turn on the number of volumes, okay, we have V1, that is the green one, and the V2 is the one in purple, let's say. So we have to, instead of create, we have to delete the volumes and below. Volumes only means we have area there, area lines, key points associated with this volume. So if we didn't define the volumes and the below, we didn't delete volume and below, the areas will remain there. So it's better to have complete delete volume and below. Pick or oops. Okay, I made a mistake again. I was trying to delete just number 2. But it's fine. We can start from the beginning with 0.9. 0.8 to 0.9 and with a depth of 10. And I can use apply there. With the function of apply, this dialog is still there. So now from 0.9 to 1 and with a depth 10. Now, okay, we have two cylinders there, okay. Now if we want to cut some part of it, we can do that. I will create a partial cylinder now with this 0.9 to 0.10, but I will have a degree, let's say a negative 10 degree to positive 10 degree. The depths I will, just for simplicity, I will put a 10. This is along the full length. Or let's say put 1 there. Okay, not along the full length, just part of it. No, this is not the things I want. And Y. Thickness. I think there's a problem with this R2. Let me check.
Isn't the other radius supposed to be 1 and not 0.1?
Yeah, I think here this is supposed to be 1, and I made a mistake. I input 0.1. Yes. I think this is the problem. Yeah. With this way, you can check what you have did, what value. I mean, I was using the radius number 1, 0.9, and the second radius, I was supposed to input 1, but mistakenly I did it 0.1. That's why it happens. So I have to delete this volume, and below I can simply click this one and OK. Okay, now it disappeared. So I will create again the volumes partial cylinder with this one 0.9, this one 1, degree negative 10 to 10, depth of 1. Okay. Then you see here we have dashed line, meaning we have overlapping area there. Sorry, overlapping volume there. So what I did with subjection, now let's go to operate. Volumes, subject, volumes. Better with options and volumes. Okay, then you can type here a volume, or you can select. So I have to make it in fit view, and I will try to select, I will cut this number 3, the small one, apply out of see, sometimes it may not be that easy to select. You have to check. You can hold your mouse and to move it to see what is in color, like this. And OK. And you want to keep or delete this one. So the base volume will be deleted, and the subject volume will be kept. Okay, let me list number of volumes. There's supposed to be 3 there. Okay, 1, 2 with the full length, and 3 with this small part. I will try to subject it. And or maybe I have to select this big one. So I will try to turn on the number of the volumes. Yes, they're already on there. Plot volumes. Okay, this one I will select this. This is 3. The 1, 1, 2. I will check it in this view. Number 1. Okay, this is supposed to be number 1. And this is number. What is the number? Check here. Oh, I can use select entities, volumes. I will unselect. Okay, this number 2 inside. Okay, because number 2, I won't use it at this moment. Okay. No, I did it wrong. So select everything. So select entities. Unselect. Okay. I was trying to select the middle, the one in the middle. It's supposed to be number 1. Okay. Okay, replot. Yes, now we have just these 2. So I'm going to subtract this 1, okay, from the big one. Okay, deleted. Keep. I'll keep and delete. I think the orders matter. Maybe I have to select firstly the big one and then the small one. And then with delete and get. Okay. Now we have this in red color with volume number 4. So if we select everything now and list the number of volumes, it's supposed to be 3. But there are 1, 3, and 4 because the second one was the full cycle and it was deleted. I mean, the second one now becomes 3 plus 4. This is the original 2 before. And this number of volumes or number of other things, they won't be rearranged. I mean, the number 2, since it has been deleted, so the new one will follow by 3, and that's number 4. Okay, basically we have, this is a kind of modeling technique, but then this is a function of subtraction. Yesterday there was a question regarding the difficulty using this subtraction. And yes, I think you can, since we have function of this partial cylinder. So alternatively, in another way, you can directly use this theta angle, okay, to create this different number of cylinders. Okay, then let me see. I will try to mesh this model now, okay, to see if we can have it. But what I did before in the slide is, for this part, I made more separation of this cylinder. And also in this line, I made it like this, okay? The idea to have this different division of geometry is just to have a better connection of element size here or there. But I will try to do a mesh. Yes, mesh attributes, we have to apply it for all volumes. With this thing, we can just use the default setting. because we have no more than one element type or material type. There's only one option there. Okay, then we can go to the mesh tool. For instance, let's use the smart size mesh big O. Okay, it's done a mesh, but I would say it wasn't so satisfactory. But even we can do in this way to have a calculation with this type of elements, but it's not rather regular. For this pipe, I think it will probably be fine because we have a more regular shape. It's just a tube. It's not complicated. But for a ship section with many stiffeners and brackets, let's say, and probably you have to have a better mesh. And one thing I forgot, we plot, is to delete this one. So when I have to delete this volume, number 4, I think it's a number 4. So it's meshed and cannot be deleted. I have to clear all the mesh. Pick all. And now let me try to see if I delete number 4. No. I think that is number 3. So unfortunately in ANSYS there is no undo function. So probably you have to start. So here in this case, I delete a wrong volume. So what I can do, if I have kept every step in this macro, it will be better. Then I can resume everything there. But now it's not possible to do that. So I will go to my log file. I can have everything before this v delete. Okay, I can copy paste. Actually, there are many commands not useful. Can be here, or can be even there. But at least I can recover the things that I have. So I need to clear. Paste, enter. Okay. So now they mesh it, and I clear the mesh. Of course, you have to kind of tidy up the macro file. Or yeah, now I have this one, and this V, I will check carefully what is the V number. I can select entities, volumes by peak from 4. Okay. I will try to select this one. This is number 3. That is number 4. Okay, I will try to do it in this way. I will select volumes number, okay, by number 1. Okay. So this is the number 1, the inner one. And I will select number 2. Number 2 doesn't exist. Number 3. So let me count how many commands I need to have there. 1, 2, 3, 4. Yes, only 4. I had 1 more. So this is the V minimum, minimum number of volume. Like this one. So this is number 3. Number 4. Okay, this is number 4. Yeah, number 4 without 3. So I was trying to delete the, now I have to select all. I can use APDL or cell. And I will need to have delete v delete number 3. Okay, so it has been removed. Then I will try to again to mesh it. Let's use this mesh tool with a smart size, free mesh, pick all. So still there is a successful mesh. If we can check here, okay. Yeah. So in this way, we have already finished the mesh. So let's check how many elements do we have there. List elements. There are 78,000. Okay. And of course, you can now we can remesh it with a relatively coarse mesh with value 10. I will pick all again, and they will ask you, do you want to remesh it? I mean, to overwrite the existing mesh. Okay, so probably they are larger, relatively larger element size. Then in this case, if you check the number of elements, they are 8,000 only. And now let's do it with the finest mesh number 1. And probably it will need some time, maybe a minute. Okay, it takes, okay, not so much time. So if we list the number of elements, there are 131,000. Okay. But let's compare with this model. Okay. So this one, of course, the element size I said is large, but they are more with regular shape and is recommended. But I didn't say if you have this type of mesh, I didn't say it's impossible to be included in a report. You can do it in this way if you prefer it. Okay. Today, basically, I will show only this part. And now we have some time for questions. I will try here. If you have no more questions, I will try here another way. I will just to clear everything. Okay, it was empty. And I will start to create just modeling a partial cylinder. I will say I prefer to do it with this radius 1, 0.9. The orders doesn't matter, 0.9 to 1 or 1 to 0.9. They both okay. With 10 to 350 with a depth of 10. With depth of 10, okay. Let me think, or depth of 1. Then I have this one, okay. I will create the other one from the same 1 to 0.9 with 10 to 350 and with a depth of. Now I have to do a local coordinate system to global Cartesian, sorry, local coordinate system. Or let's say offset the WP to XYZ coordinate. Let's say equals 1. No, not here. Create local coordinate system at WP origin. 11. Okay. I was trying to create a local coordinate system by 3 nodes, by key points, specific location. I don't know if this works. 0 and 0 and 1. Okay. CSY. CS11. Let me check what they did there for the local. It's a local. So it's local is 11. And next is X, no, Y, no, Z is at 1. So in this way, I create a local coordinate system 11 here. Then this partial cylinder will follow. We're starting by this, starting from this 1. So I will say this is 0.9, and we have 1 there. We have 1, 2, 3, 50 with depths of 4 more or 9 more. Apply. Okay, so they're there. And now we do 0.9 to 1 until 1.1 with negative 10 to 10 with depth 9. Okay. Oops, there's something wrong there. Let me check what is problem. So we have to delete this 2 to 3. Yes, I have to move this with activate coordinate system. Let's say 0.921 and 10 to 350 is 9. Okay, it's there. And what I want is also from 0 to 9 to 1, negative 10 to 10 with a 9. So this is another way to directly create this kind of partial cylinders. Okay, it doesn't use the function of subtraction, but with this way, maybe you think it might be easier. This is also possible to have. You just control the degrees for this partial cylinder. Okay, with this, I think we can stop here. Next week, on Monday, I will give a presentation, the last one, regarding how we do this analysis and result check on Tuesday. And then the rest of the time, classes for this month, they are for the practice. It's possible to schedule some ANSYS tutorial, or you can ask questions in your case. I mean, you can share your screen of your ANSYS and to ask questions what was wrong there. So basically, you have to start it as soon as possible. Even I understand many of you have many projects or classes to do, but if you start better, then if you have any problem, a question, you can ask me and we can solve it together during the scheduled time for our classes.